episode of Additional Math. Today we're going to look at vectors. I think some of you have issues with constant velocity problem. So we want to go through the concept behind that and actually also go through one of the exams question on how to solve it. Alright, so let's start off with the most fundamental part of constant velocity problem. So in general, we want to identify certain quantity as either scalar or vector. Now, scalar basically means that the quantity has only magnitude. All right, magnitude, yeah, magnitude. Now, what it means is basically is that it doesn't have any direction. It just tells you, hey, I'm going to go here and this is my quantity. For example, like speed, right? If we are going at 3 meters per second, it doesn't really say whether it's going to the left, to the right, up or down. All right, it's just a magnitude. Other things, for example, like distance. Distance has no direction. It just say 2 meters, 3 meters, and so on. Whether it's to the left, to the right, doesn't really say anything. So it is just a form of scalar quantity. Okay. Now for vector is a bit different. It has both magnitude and direction. All right. And direction is very important because it tells you where the quantity is actually exerted towards. All right. Sometimes we can talk about forward direction, upward direction, some 45 degrees to the east or 45 degrees to the west. So basically, vector has some sort of direction attached to it, right? Apart from just a magnitude. So things like velocity, all right, things like displacement are essentially vector quantity. So it kind of have the same unit, all right, just like a scalar quantity, but it actually tells you the direction. So that is the main difference. Alright, so the whole idea of constant velocity problem is that we are able to actually find out the direction or the position of a particle or an object at any given time, assuming that we know the velocity, and that velocity is actually constant. If it's not constant, then it's a bit more difficult to solve that. We may need to use calculus to solve. Alright, but at your level, we will assume constant velocity. Alright, so let's look at example 1 to help us to understand how to break up a scalar quantity, and given some direction, we can break it up into the horizontal and vertical motion. Alright, so let's look at this example. I'm traveling at 4√2 meters per second in the northeast direction. What is my velocity broken as the horizontal and vertical motion? Okay, so what I'm going to do, I'm just going to draw the diagram first. All right, so northeast direction, so it's gonna be somewhere around here, right? This is northeast, and if it's perfectly northeast, then I know my angle here is 45 degrees, and I know my velocity is 4√2 meters per second. Okay, so this is my velocity, all right, because I'm given the direction. Meaning to say that if I were to design a right angle triangle here, 4√2 will act as my hypotenuse, right? Now, obviously, going to 4√2 in the northeast direction, I am actually moving some sort of, or somewhat to the east, and also somewhat to the north, isn't it? I'm moving some amount of east motion and some amount of north motion, all right? So basically, this sets up my horizontal and my vertical component of this velocity. All right, so obviously the one going to the east will be my horizontal. I just put horizontal here. All right, vertical will be going up. All right, so this is my vertical. Okay, so how do we break this up into the horizontal component and vertical component? We will use trigonometry to help us. All right. So this would, the vertical side we try to find, but that is like my opposite, and 4√2 is my hypotenuse. So I'm going to say sine 45 degrees is equals to the opposite, which is my vertical, over my hypotenuse, which is 4 root 2. Okay, and yeah, so I know my vertical component will be equals to 4 root 2 sine of 45 degrees. Okay, sine of 45 degrees. Alright, so what is sine of 45 degrees? We can work using our special triangle. This is 45, this is 45 degrees, this is 1 root 2. So OH. So sine 45 is 1 over root 2. Alright, 1 over root 2. So we can cancel. So my vertical side will be just 4 meters per second. Alright, so I'm going upwards 4 meters per second. Okay, if you just isolate the vertical part. Now, similarly, if we want to work out the horizontal component, then horizontal part will be my adjacent, right? A. So I'll use cosine 45 instead. So cosine 45 degrees will be adjacent over hypotenuse, so 4 root 2. So to make the horizontal part, I just rearrange my equation, so it's the same, I think it's the same answer, 4 meters per second, right? Because cosine 45 is also 4, it's the same as 1 over root 2, so multiply the same. Okay, so therefore we can say that our vector, alright, our vector going northeast direction would be 4, 4, right? 4 units to the right and 4 units up. Alright, so the horizontal and vertical component 4, 4. Or you can say, okay, I forgot the unit. You can say it's 4i plus 4j, alright, meter per second. So that's another way to represent that. Or you can use 4a plus 4b meter per second. Now, either one of this would work, alright, to kind of explain where is the horizontal component and where is the vertical component. So knowing the vertical and horizontal component of a motion, I can always work back using Pythagoras to know the exact velocity. Alright, so if you're going to try the square root of 4 square plus 4 square, you should be able to get 4 root 2. Okay? So I'll pause here if in case you want to go through and understand and take down notes. Alright? Okay. Now, let's look at example 2. Kind of similar to what we have done in example 1, but let's look at what's going on. Alright, so example 2, we have a velocity of a particle traveling at a bearing of 120 degrees at 20 meters per second. Okay, so even before I do, okay, and they want the horizontal and vertical component of velocity. Okay, so let's draw the diagram first. 120 degrees, alright, so my bearing would be something like that, right? This is 120 degrees. Okay, so the angle that it makes here has to be 60 degrees, isn't it? Alright, and the velocity is going at 20 meters per second. Okay, so we want the vertical and horizontal component of the velocity. Okay, so obviously going in this direction here, I am going down and I'm going to the right. Alright, so my vertical component would be a negative value because, yeah, kind of going down. Alright, so let's work out using trigonometry. If you know that this is 60, this would be 30. Alright, I don't know which one you prefer, but it doesn't really matter, both is fine. Okay, so let's work out the horizontal component, which is this one. This would be my opposite, assuming I'm using 60. Alright, so we will use sine. So sine 60 degrees is equals to the opposite over hypotenuse, which is 20. So my horizontal component is 20 sine 60 degrees. Alright, so what is sine 60? Just use our special triangle. Let's look it up quickly. 1, 2, root 3. This is 60. So OH, root 3 over 2, right? Yeah, root 3 over 2. So 20 times root 3 over 2. So it's 10 root 3. Okay, meter per second. So that's my horizontal component. And it will be a positive value because it's going to the right. So going to the right is always positive. Going to the left would be negative. Okay, so that's that. Now let's work out the vertical component. We're going to use a cosine instead. Alright, so cosine 60 equals to adjacent over hypotenuse. In this case is 20. So our vertical component, it is 20 cosine 60 degrees, which is cosine 60 is half, yeah. So it will be 10. Okay, but the problem is that for vector quantity, there is direction, and in this case vertical is not going up, so 10 meter may be quite confusing. You may think it's going upwards, but actually it's going downwards, so we're going to put negative instead. All right, so therefore our velocity broken into the vertical and horizontal component would be 10 root 3 and minus 10. Okay, meter per second. All right, you can of course show it in the IJ format, Okay, so generally we just use either one of this. Okay. All right, so maybe you can pause the video and try this again yourself and see if you can do it. All right. If you're done, you can unpause the video and watch the next part of this video. Okay, now the last part to this, before we look at the exam example, is actually position vector of a particle. All right, so a position vector of a particle basically wants you to find out where is the particle at any given time. Okay, so let's assume we know that a particle current position is at A, which is 2, 3. Okay, so 2, 3 from 0, 0. Okay, and the particle is moving at 2 minus 1 meter per second. All right, that is the velocity vector. So meaning to say that at various time, the object will be moving 2 units to the right and 1 unit down, all right, per second. And then this will carry on as the particle moves, right? So after 1 second, when t equals 1, for example, the particle would have moved 2 units to the right and 1 unit down, right? So the new position would be something like 4, 2, correct? The new position, A2, all right? Because that's 1 second later. And then you see that these patterns will happen as it moves all throughout this direction, all right? So the direction where the object is moving is actually dependent on the vector, the velocity vector, right? So all in all, we can find any position of a particle using this formula, where r equals to a plus vt. All right, so what is r, what is a, what is v, what is c? So r is basically the position vector of the particle. So wherever it is, that's the r position. A would be your original position of the particle. Original position, or we can say the starting position, original position of the particle. So we need to know where it started from, right? So then we know where it's going to move ahead. All right, v of obviously would be the velocity vector, and we need to break it up into the horizontal and vertical component. All right, and t would be the time. Yeah, so all in all, we can use this formula to help us to represent this situation. So R will be the position of the particle, will be 2, 3, which is the starting position of the particle, plus 2 minus 1, which is the velocity vector, times t. Okay? Alright, so with this formula, any given time, I know where my particles is going to be. Okay, so for example, at time equals 10. Alright, so my R value will be 2, 3 plus 2 minus 1 times t times 10, sorry. That will be 2, 3 plus 20 minus 10. So that will be 22 minus 7. Alright, so this will be the position of my vector when time is 10. Okay, so it will be 22 units to the right and minus 7 units down. Okay. Alright, so I hope this explanation is clear on how you find the position vector of a particle. Alright, so the next part of the video, we are going to go through the example or the question in your exams.